15 billion miles from Earth, a machine built in the 1970s is still talking to us. And for over a decade, it's been sending back something scientists never expected to hear. A sound. A low, steady hum coming from the empty space between the stars. Right now, piece by piece, that machine is being switched off. Every year, engineers race to keep it alive long enough to answer one question. What else is it hearing out there before it finally goes quiet for good? Voyager 1 launched on September 5, 1977, riding a rare planetary alignment that let it slingshot past Jupiter and Saturn before being flung toward the edge of the solar system. It was never designed to last this long. Its primary mission was expected to end after just a few years. Instead, Voyager 1 kept going. For decades, it traveled toward the heliopause, the outer boundary where the sun's solar wind finally loses its grip and meets interstellar space. In August 2012, its instruments recorded a dramatic shift. The density of charged particles increased, and the surrounding environment changed. Voyager 1 had crossed the heliopause, becoming the first human-made object ever to enter interstellar space. There was no dramatic flash or visible boundary, only data traveling across billions of miles, revealing that humanity had crossed into a region no spacecraft had ever reached before. But the strangest discovery didn't come from crossing that boundary. It came from an instrument called the plasma wave subsystem, built to detect oscillations in the ionized gas surrounding the spacecraft. In 2013, the instrument detected something unexpected, a persistent, tone-like vibration in the plasma itself. Scientists used it to measure the density of the interstellar medium with remarkable precision. They never expected interstellar space to have a voice, yet it did. The faint hum wasn't created by intelligent life. It was produced by plasma oscillating as shock waves from powerful solar eruptions traveled outward through space, remaining detectable even billions of miles from the sun. For more than a decade, researchers have continued studying this signal to map the structure and density of the space between the stars. In a very real sense, it is the sound of interstellar space, and Voyager 1 is the only spacecraft capable of hearing it. Attached to Voyager 1 is the famous Golden Record, carrying greetings in 55 languages, music, natural sounds, and recordings of life on Earth. It was designed as a message from humanity to the universe. No one imagined that the spacecraft carrying that message would one day send something back. Not music, not words, but the first direct signal ever recorded from the medium between the stars. Voyager didn't just carry humanity's voice into the darkness. It discovered a voice that had been there all along. Full memory readout came back to Earth, and by comparing it against an old copy from years earlier, engineers finally found the wound. A single memory chip, responsible for storing part of the flight computer's code, had failed. Roughly 3% of that computer's memory was simply gone. Nobody knows for certain whether it was a worn-out component finally giving up after nearly 5 decades, or a single high-energy particle from deep space striking exactly the wrong transistor at exactly the wrong moment. Either way, the team rewrote the lost code from scratch and found room to store it elsewhere in the spacecraft's memory. Voyager 1 spoke clearly again, but the fix was a patch, not a cure. What makes these episodes so unsettling isn't just the mystery, it's the wait. Every command sent to Voyager 1 takes over 23 hours just to arrive, and the reply takes just as long to come back. There is no live troubleshooting at the edge of the heliosphere. There is only patience and a team that has spent decades learning to read a 50-year-old machine's silences as carefully as its words. Underneath every one of these glitches sits the same unforgiving constraint: power. Voyager 1 runs on 3 radioisotope thermoelectric generators, devices that convert the heat of slowly decaying plutonium-238 into electricity. There is no way to refuel them, no way to repair them, and no way to stop the decay. Every single year, the spacecraft loses about 4 watts of available power, permanently. By April 2026, those generators were producing less than half of what they delivered at launch. The danger isn't hypothetical. During a routine calibration maneuver in late February 2026, Voyager 1's power level dropped unexpectedly, coming dangerously close to triggering an automatic failsafe that would have shut the spacecraft into a defensive safe mode. a state so risky to recover from at this distance that engineers describe it like a trapeze artist letting go of the bar. To stay ahead of that cliff edge, mission engineers made the call. On April 17, 2026, they sent the command to permanently power down the low-energy charged particles instrument, a detector that had run almost continuously since launch, central to identifying the very boundary Voyager crossed back in 2012. Of the 10 original instrument sets each Voyager carried, only 2 now remain active on Voyager 1, the magnetometer and the plasma wave subsystem, the very instrument that first caught that interstellar hum. As mission manager Kareem Badruddin put it, shutting down a science instrument is never anyone's preference. But with 2 irreplaceable instruments still returning data from a region of space nothing else has ever touched, keeping the mission alive matters more than keeping every sensor running. Engineers haven't given up on the instrument entirely. They're testing a longer-term rescue plan, nicknamed the Big Bang, swapping failing power-hungry components for leaner replacements, potentially freeing up enough electricity to bring the shutdown instrument back online. It's being tested first on Voyager 2, which has a little more power margin to spare. If it works, engineers hope to attempt the same fix on Voyager 1. Even in the best case, the math only bends the timeline. It doesn't break it. Voyager 1 is projected to cross 1 light day from Earth in November 2026, a distance so extreme that a single round-trip conversation, a command sent and a confirmation received, will take a full 2 days to complete. Engineers expect that, sometime in the 2030s, the power margin will finally shrink past the point where even the last science instrument can be kept alive. When that happens, Voyager 1 won't stop existing. It won't stop moving. The golden record, carrying the sounds and images of Earth, will still be bolted to its side, drifting on for billions of years after everyone who built it is gone. But it will stop being a source of new knowledge. A working spacecraft is a conversation. A silent one is simply an artifact, the farthest one humanity will ever make. For now, though, the conversation continues. Somewhere past the edge of the solar system, an antenna the size of a small satellite dish is still turning toward a star. It left behind 50 years ago, still listening to a faint, oscillating hum in the plasma between the stars, and still finding a way, against every reasonable expectation, to answer